My lab is an interesting mix of remote sensing work and economics. And so we're often combining machine learning methods, we're using big NASA data sets, but then we're applying methods from economics that are very quantitative to try and understand how do people conserve natural resources? How do they protect forests? What kinds of policies actually work? And so that often means finding a student who's really passionate about the environment. They have kind of connections, they have experiences that have made them really care that that's what they want to do. But then also that they have fundamental training from their undergraduate that prepares them for more rigorous quantitative methods. And that's what the set of tools that they want to use to kind of pursue the thing that they care about.
My research is focused on using remote sensing with machine learning and causal inference approaches to explore the impact that humans have on the environment and vice versa, how the environment affects us. In my current project, using weather radar to track bats and then quantifying the ecosystem services they provide to farmers here in California. And to do this, I rely on remote sensing, I rely on machine learning, and I rely on econometrics or causal inference approaches developed by economists. And Robert is a trained economist. I lean really heavily on him and a couple of my other committee members to really beef up my data analysis approaches.
One of the challenges doing interdisciplinary work is it's often lonely. There's no clear path to follow. And so I think it can be really vulnerable for students. And so a lot of the work that I do in my lab, through our lab meetings, through kind of hikes in the hills together, is building a foundation of trust where students can really work with each other and push each other to grow, but in a way that's supportive and collegial, and finding that balance between pushing your colleague to be better while simultaneously feeling like they have your best interests at heart is a really important skill that I think allows you to do better work when you're working across disciplines.
Projects change very quickly, especially interdisciplinary projects where data sets might not be completely available, or locations might change, or even questions might change. And so being able to pivot, I think, is really important. And also surrounding yourself with an awesome committee that provides mentorship, but also has patience, I think, is really important.
I see all the different ways that research can really create a fulfilling and exciting career. And so I think especially for interdisciplinary environmental students, being open to the many pathways they might want to pursue from the beginning of their PhD, and really listening, engaging, getting to know them personally, and seeing which of those pathways really aligns with their priorities, their interests, their career ambitions, and being supportive of whatever that happens to be. Brian's kind of the ideal student that you hope for in an interdisciplinary program. He really brings this interesting mix of training in machine learning, of kind of an interest in ecological questions, and then this openness of learning methods from economics, melding all those together to really do kind of cutting edge research that transforms our understanding of ecosystem services. That for me is an opportunity to learn from my student, which is really the biggest joy of being a professor, is you get to see new questions that you wouldn't have asked yourself. You get to learn from the student and collaborate and do cool research that wouldn't be possible otherwise. And so that for me has been a real delight of working with Brian.